Good afternoon, everyone. We are Group 12, and we are here to talk to you about COVID-19 detection with chest radiographs. We are Poyang, Yuting, and Tinghui. COVID-19 is an international health issue. Though it can be diagnosed with PCR, it takes so long to get the results back. More and more people need to get tested as the pandemic getting worse these days. To reduce the overwhelming medical system, faster diagnosed methods that has been introduced such as rapid antigen test. However, the accuracy is not as good as PCR. So we like to present a method to detect the COVID-19 lesion with radiographs.
In our final project, we have two main goals. The first one is to do localization. We have to know where is the lesion detected. And the second one is to do classification. We have to know what the disease is. So we think that the convolutional network can help us tackle this problem. We found some status bars like RCN region with CN features. YOLO, you only look once, a vision date. Our data sets come from Society for Imaging Informatics in Medicine. There are two labels. The first one is the image label. It is a bounding box problem. And the second one is the study label. It is a classification problem with 4 categories. And now I'll introduce my faster RCN implementation. Faster RCN is an object detection system using regional proposal network. It is more accurate, but it takes longer time to inference. In my training, I have done normalization, data augmentation, and I have tried a lot of different hyperparameter settings. But in my training, I found that it converges in only 1 or 2 epochs, so I only trained for 5 epochs. In this graph, I show you 2 training loads because in my different hyperparameter settings, I found it converges almost the same time, and their loads are around 0.3. So I decided to show you that they are very similar. And this is my result. The left one is the original radiograph, and the second one is my network inference where the lesion may occur.
And we also choose another model which is called YOLO V5. YOLO V5 is an object detection system targeted for real-time processing. It has an advantage to generalize image better and faster speed. However, YOLO V5 imposes strong spatial constraint on bounding box, so it is hard to detect small or close objects. And here is our training details. We have tried different hyperparameter, and here are the one that we choose for the training. And here's our model performance. As you can see, we have the precision of 0.56, which is higher than the faster RCN, and although we didn't share on the previous slides. And for the result, on the left side is the image we input into the trained model, and on the right side, the bounding box showed the prediction of the location of the lesion. And the number on the figures, 0.77 and 0.68, means its confidence. To conclude, our training deep learning model can successfully detect the location of the lesion, and in the future work, we hope to finish the identification of the disease with the located lesion. And thank you for your listening.